Alright, so what we want to do now is have a look at question 4, which is pretty much exactly the same as question 3. The only difference now is that we have a different standard deviation and a different mean. And they're kind of inconvenient when we look at the probabilities that we want to calculate. So if I was just to draw up exactly what it is that we want to calculate. So here's the normal curve. And the high point must be at 2.4. One standard deviation to the right of that mean is going to be 2.4 plus 1.2, which will give us 3.6. And then one standard deviation to the left of that mean is just going to give us 2.4 take away 1.2, which is just 1.2. And I better label this up just with an X. And the thing is, I see what we want to calculate here. We want to calculate the area under this curve from like 3, which is about here, all the way up to infinity. So we want to calculate this area in here, where this is just 3. So it's going to be halfway between those two. And the trouble is that 3 is like, well, it's half a standard deviation away from the mean. So the picture that I had before isn't going to really be helpful. So we are actually going to have to use the calculator in this case. But that's exactly as it was before. So if I write down this again, I want to calculate the area under the graph from 3 up until infinity. So if I bring the calculator back, so our lower one this time is going to be 3. And then, well, an upper one, pretty much we just have to choose any big number that we want, as long as it's big enough. So again, 1 million will probably do for us. And the standard deviation was 1.2, and the mean was 2.4. So I'll just write that down. So the person marking this, or marking whatever I do, can see that I kind of know what I'm doing. And that's equal to 0.309. And that's it. That's the probability that this random variable x, whatever it happens to be, is going to be greater than or equal to 3 if we were just to go up and measure it. So it's the same kind of thing for this one here, except that instead of going up to some really, really big number, we're just going to calculate it between two much smaller ones. So wherever this is, we're going to have like 2 here, and then 3 on the other side. So what we want here is just this area in here. So if we were to calculate that, what I'm going to put into my calculator is this. 2 is going to be the lower, 3 is going to be the upper, and the standard deviation and the mean are just the same as they were before. So that's just 0.322. Now for part C, it's going to look just like this again, except that there's a little 2.1 over here, and I just want to calculate the area back this way. Well, let's draw it up anyway. And then somewhere over here we shall have 2.1. And we want to calculate the area under the graph so that x is less than 2.1. So where x is less than 2.1 is just going to be this area all the way over to the other side of the universe to the left this time. So here, so this is 2.1. So what we need to put into the calculator is first of all a really, really big negative number instead of a really big positive number, because if I keep going this way for a very long way, then I'm going to end up at a really, really big negative number. So let's choose, actually 1,000 will probably do. And we want to go up to 2.1. And the standard deviation was 1.2, and the mean is 2.4 again. So if we stick that into the calculator, first of all we put in our really big negative number, the more reasonable number that we want to go up to, and the standard deviation and mean are the same. Whoops. So we get 0.401 there.